Welcome to Study Loop.
So here we are given water that is being boiled at a constant pressure of 2 atmospheres and at a temperature of 120 degrees Celsius. Since it is boiled at a constant temperature, when water changes from liquid state to steam state, to the gas state, it changes its volume. Of course, its volume is rapidly increasing, and this increase in volume, which is given in the problem from initial volume V1 to final volume V2, this change in volume is corresponding to certain work done. So for the part A of this solution, we need to evaluate this work that is being done while the water is being evaporated. So for the total heat of vaporization, the heat of vaporization was given also in the problem. The work done to vaporize the water will be the work done. And here we can use a standard formula for constant pressure work. So at a constant pressure P, the work will be only related to the change of volumes. So here we can immediately substitute the known values. So this is going to be 2 times 1.013. This is conversion from atmospheres to pascals, times the change, which is going to be from 0.824 meters cubed minus 1 times 10 to the minus 3 meters cubed. And this will finally give us work that equals 1.7667 times 10 to the 5th degree joules. So here we know the work done for the vaporization of the water. Now for the part B of this problem, we do know that we need to find this internal energy from the first law of thermodynamics. So for the part B, we are given the heat of vaporization. And this heat of vaporization represents the heat that is added to the water to vaporize it, and of course, consequently increase its internal energy. So internal energy will be increased by the vaporization process. So from the first law of thermodynamics, we know that the change of internal energy will be the difference between the heat that is being added into the system minus the work done by the heat. So we have some amount of energy that is being given to the system and some work done. The rest, after we subtract what energy is getting lost due to the work done, what is left is only left inside the system, and this is the internal energy of the system. And here we can simply substitute, since this is QV, the vaporization heat that we already know, and the work W that we already evaluated. So this is going to be equal to 2.2 times 10 to the 6th power joules minus 1.67 times 10 to the 5th power joules. Putting this into a calculator, we obtain that the final internal energy increase is equal numerically to 2.033 times 10 to the 6th power joules. And by this, we have finally solved the part B of the problem, and the whole problem is solved. So I hope this was helpful to you, and I hope to see you in the next lesson.